we're given the chemical reaction of ethanol with oxygen. So we have C2H5OH, which is ethanol, plus 3 molecules of oxygen, give us 2 molecules of carbon dioxide gas and 3 molecules of H2O gas. Now this reaction produces 8 liters of gas at a temperature of 365 degrees Celsius and 120 kilopascals. And we need to determine the mass of the reactant needed for this. Okay, so in general, we probably want to find the number of the moles of the substance in question. So in this case here, we're given 8 liters of gas as our product. So what we're going to do is we're going to convert that 8 liters of gas to the product quantities of moles. So here the product quantity of moles are going to be the moles of CO2 and H2O. Okay, that's our product. And we should often do this at STP. So I've made a note here, it's often useful to have it in STP when we're dealing with these chemical reaction equations, when we're doing the stoichiometry. Okay, so our first thing then is we're going to convert those 8 liters of gas. So I have to start with 8 liters of gas, and I'm going to convert that into moles of the products. So I'm going to convert that into, there's 1 mole for 22.4 liters of gas. Now if I'm going to use that 22.4 liters of gas, I have to convert it to STP. So this temperature, that 8 liters is measured at 365 degrees Celsius. I need the temperature at STP. I need to make my volume smaller. So I end up with 273.15 kilopascals. I'm going to put that in the numerator and the bigger number in the denominator. So the 365 degrees Celsius converts to 338.15 degrees Kelvin. Sorry, that's not kilopascals, that is temperature. So degrees Kelvin and degrees Kelvin. Okay, so I need to have this at a lower temperature, which is going to lower the volume, so I need to have the smaller number on top. And then I also need to convert this into 101.32 kilopascals. So that's going to be going from 120 high pressure to low pressure, so I'm going to increase the volume. So that means I need to make sure that my bigger number, so 120 kilopascals, is on top. 101.325 kilopascals is on bottom. So again, I've gone from a high pressure to a low pressure. That means the volume is going to increase, so that I make sure my ratio reflects that. And a couple things to note here is that the units of the conversion, the ratio conversion for temperature and pressure, do not change the volume units. Okay, so when I do my unit analysis here, the liters cancel out, these cancel out, these cancel out. I'm left with the number of moles of the product gas. So when I work this out, I get 0.181 moles. And this represents the product gas. Okay, so that's my product gas is 8 liters. And so I've converted that into moles of product gas. And that's on the product side of the balanced equation. So if we take a look at this product, we have 2 CO2 plus 3 H2O. That's on our product side. This has a net of 5 units of product. Now what I really am interested in is actually the ethanol on the other side of the equation. So I have 1 C2H5OH plus 3 O2s. I'm not that interested in the O2s. What I'm interested in is that 1 molecule of reactant. So now I have the ratio of 1 mole of product for every, 5 moles of product for every 1 mole of reactant. This is my reactant amount, so then I need to convert that into this is my product amount over here. I need to convert that into my reactant amount. So I'm just going to divide by 5. So I got 1.81 moles of product gas, and I'm going to times that by 5 moles of product gas for 1 mole of reactant gas. And this is my C2H5OH gas, or sorry, not my gas, but my reactant molecule. And so when I do that, I end up with, in this case, I have my, working out that value, I end up with 0.181 divided by 5. It gives me 0.0362 moles, and this is the reactant gas. Okay, so that's how many moles of ethanol I have, or C2H5OH. Sorry, this is not reactant gas, but reactant. Okay, so I could really do this last part in one step. So once we have the balanced equation, we can use that ratio to convert it into moles of product to moles of reactant, or whatever ratio I need to use to determine the part of the equation I'm trying to find out. So in this case, I had 5 parts of product to 1 part reactant, and so once I figure out the total product, I can work out the amount of reactant I needed. And then we need to then do the calculation of converting that moles into, in this case, the question's asking for the mass of the ethanol. So I'm just gonna start with the moles of product gas. So 0.181, this is product, times my conversion factor, 1 mole of C2H5OH for 5 mole of product. Those are going to cancel out. And then once I have the moles of C2H5, I need to then convert that using the molar mass. So the molar mass of ethanol works out to be 46.07 grams of C2H5OH for 1 mole of C2H5OH. These cancel out, so I end up with 0.181 divided by 5 times the 46.07, or we could just say this number of moles times the molar mass, and we end up with 1.668 grams of C2H5OH, or ethanol.